All right, where do you crazy kids want me to start? 10?
Yeah, we didn't get to 10. We said we'll do that tomorrow.
Oh. Oh, yeah, that's right. Oh, yeah, this was crazy. All right, number 10, write equations for the given tables in both recursive and explicit form. So for number 10, to do that in explicit form, can I help you something? You're just side-eyeing me, as my wife would say. She hit me with that one this weekend. Don't sit over there on the couch and side-eye me. Mm-hmm. Like, it's like this, like I'm watching TV, she's over there learning Italian, and I'm like, yeah, kind of, right. Yes. Okay, so we started this like a long time ago. We did this stuff. What are we going down by each time? -3. So probably don't remember what that means. It's going to be -3n. It's going down by 3 each time. And then in order to figure out what we have to add on to that, we have to figure out what the number before the 5 would be. 8. So it's -3n plus 8. Is that what you're going to say, Dylan? No. What do we have? 3 weeks? It's possible. Hard to say. Huh? If we did, we would review before. Maybe. Mm-hmm. Be able to use notes, you mean? Yeah. Yep. 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 Okay, then the recursive we haven't talked about very much, but recursive is just what are we doing to get the next number? You're minusing 3. So the way that you write that is you go, I think they use a little different notation in this stuff, but it's this, you go to get the next one, you take the one before it, and you subtract 3. Yeah, I think they go f of n maybe equals f of n minus 1 minus 3. So this is the, yeah, it's something weird like that. So this is the next one, this is the one before it, okay? All right, so then if we take a look at number 11 and we go, okay, that's easy, you just do the same thing here. This is going up by 6, but sadly, the next one is going up by 12, so it's not arithmetic, it's not a linear one. Multiplying by 2, good. So that means we would say 2 to the n, but then we have to figure out again what would be the number that we would start at. 3, good. So it would be 3 times 2 to the n. Because we're not adding, we're multiplying, yeah. And then again, the recursive thingy, I'll try and use the notation that they use would be f of n equals the one before it times 2. Okay? Oh, and I think in this one you have to say what the first one is. But whatever. Okay, so what's going on number 12? Well, but this one would be plus 8, and then the next one would be plus 4. Because it's going down. But you're not multiplying by the same thing each time. Oh, they tricked us. I do too. He's the best. What? You got it? Yeah, it skips 1. Yeah. So there should be a 1 in between here. So what would this number be then? What's in between? Yeah, -9. So if we throw a -9 in there, now this is going plus 4, this is going plus 4, this is going plus 4. So it would be 4n. And now we don't have to do the next one back thingy because they tell us what it equals at 0. Yeah, so 4n, yeah, minus 13. And then the recursive one, since we're adding 4 each time, you just say take the one before it and add 4. Okay. Lindsay, I emailed you some stuff when you were gone. So you got a couple of assignments to maybe work on, sir? Yeah. Because it's like, this is the one before this one. That's why it's -1. It's like if this is the 8th term, then this is the 8 minus 1, or the 7th term. It's the one that came before it. I don't know. Yeah, it's a really awkward notation.
Why don't we go back to the
Does that make more sense? Yeah, either one is fine. If you understand either one of them, then you're in good shape. Okay, oh, we got some more of these. So now we have to be careful because they're throwing some missing numbers in here. We don't have a 2 or a 3 spot, but Luis says these two are right next to each other and they're +2. So if I did a +2 for each one of those, then it would fit, right? 5, 7, 9, 11, 13. Yeah, and then the one before this would be 3. So it's 2n plus 3. Lindsay? Oh, yeah, we did. Okay. Yeah. Okay. Okay, and then again, the recursive one would be to get the next one, take the one before it and do what? Huh? +2, yeah. Hello. Okay, so number 15, what are we multiplying by each time? Multiplying by 4 each time. So our explicit one would be, I'm going to take -4 times 4 to the n. Okay. And then the recursive one is take the one before it and times it by 4. Okay? Yeah. Because the number that gets the exponent, that's what you multiply by each time. And then the other number is the number that you start at. So what this means is, if you think about this, what this means is I'm starting at -4, and then I'm going to just keep multiplying by 4. So -4 times 4 is -16 times, yeah. Right, because that's the easier one kind of to figure out. So, but then you tuck this one in front of it, yeah. I don't want you to stress about number 14, but should we give it a go anyway? I'm going to see if it's multiplication first. Will you guys tell me what 390,625 divided by 15,625 is? Yeah. Does it come out to be something nice? 25? Okay. So what that means is, for me to get from 7 to 9, I have to multiply this number by the same thing twice. And so, I mean, we did this a long time ago also. So that means the square root of 25 is 5. So that means I'm multiplying by 5 each time. So if I went 15,625 times 5, that would give me a number that fits there. And if I took that same number and multiplied it by 5, I would get the next thing. Because multiplying by 5 twice is the same as multiplying by 25. Okay? But don't worry about that. So the explicit one is, like Dylan said, I'm going to go 5 to the n first. Then the question is, what is my starting number? So now I have to go back twice, because I just got started at 2. So what would this number be? Which is, yeah, 0.2, yeah. So it'd be 0.2 times 5 to the n. And then the recursive is to get the next one. take the one before it, times 5. Okay. Thanks, Abby. You're the best, man. Yep. Your work here is finished. You're excused for the rest of the week. Yeah. Yep, that's exactly right. Yeah, that's the number that it equals when n is 0. So that's why for that one we had to go back twice. Because that if we're multiplying by 5 going this way, then we have to divide by 5 going the other way. Because we're going the opposite direction, so you do the opposite thing. Okay? All right, I'll take those from y'all. Do you need to staple them, or are they just a one-pager? Here we go. Lesson 3. For each graph, determine if the relationship represents a function, and if so, state the key features of the function, including intercepts, increasing, decreasing, maximums, minimums, domain and range, and end behavior. This, the whole, everything. So let's get after it. Talia. Okay, so for it to be a function, it has to pass the vertical line test, which means that there's no vertical line, that would go through 2 points in the graph. So this right here, since it crosses, you need to highlight it first. Oh, since this one would not be a function, because it crosses this graph twice. What about this? Is this a function? Yes, okay. So first thing is yes, function. All right. Okay, next, how about increasing and decreasing, Jaron? Or sorry, first of all it says intercepts. Jaron, what is this graph's X and Y intercepts? Well, you got it in your packet right in front of you. So where does that cross the x-axis? Yep. And where does it cross the y-axis? Looks like we're going to have to ballpark it there. 3.2. Okay. So there are the intercepts. Okay, now let's do increasing, decreasing. Nathan, where is it increasing? Okay, good. -3 to 1. It's increasing, and it's decreasing from awesome. You guys see that? Going up from -3 to 1, and then going down from 1 to 4. Okay. Next we'll do maximum and minimum. McKenna, what's the highest y value on the graph? Highest one? 4, good. And then what's the lowest on the graph? Nope. 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 What's the lowest point on the graph? That's the highest point is at 4, 0 down here. Okay, so this is at 4, and this one's at 0. Okay. Do 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 do. What else we got? Symmetries. Luis, any symmetries? Like, can I draw a line anywhere and have that be the same on both sides? Nope. So there's no symmetry. What about domain and range? Remember, domain is the x's and range is the y's. Riley, what's the domain of this graph? What's the lowest x to the highest x? Yeah. Nope, lowest x would be way over here. Yep. And what's the highest x? Awesome. And then the range is the same thing, but it's the y's. What's the lowest y value on the graph? It would. And what's the highest y value? It would indeed. Nice job. Okay, any questions on that? We all right there? That is a lot. How many? Oh, you do? Yeah, I don't have much room either. Because the domain is the x values, and so the lowest x is -3 and the highest is 4. Okay? Do you want a separate sheet of paper to write this stuff down on? You'll just cram it in there? Just put it. Then you got it? All right. How many of these do we have to do? 5, 6, 7. Holy guacamole. Okay. I'm not worried about the room. It's just going to take forever. All right. Dylan, not a function. Nice. Because that fails the vertical line test. All right. Next question is the x and the y intercepts. So Matthew, what's the x-intercept? And what's the y-intercept? Awesome. Okay, crosses right there at the origin, 0, 0, so that makes both of the intercepts 0. Westone, I'm wondering if you could tell me where this graph is increasing and where it's decreasing. Can you girls tone it down a little bit? Yeah. I don't know, it's kind of weird because it's a... I know. I don't really know how to answer this question because it's going up and down at the same time because it's not a function. Alexa, Dylan. At this. Huh? I guess, yeah, I guess it just would be doing both. So, where is it increasing, Weston? Well, where does it start going up if you go from left to right? It's 0. And then how long does it go up for? Infinity, yeah, because those arrows on the end mean that it's actually going for infinity. Where is it decreasing? Still on you, Westone. 0. And how long does it go down for? Infinity. That's really weird. Yeah, right. But I mean, I guess it's not a function, so that's why that's kind of a weird answer. Okay, maximum and minimum. Dylan. Okay, but infinity can't really be a maximum or a minimum because if you name like infinity, then I'll go infinity plus 1. So that means that this has no maximum because it's going to keep going up and up and up forever. So what's its minimum? Right, same thing, also none. It's not 0, there isn't one. It just keeps going down and down and down. If you named a number, I could name one less than that, okay? All right, how about symmetry? Weston? Right, and so what we're looking for that answer is that it has horizontal symmetry, yeah. Okay. I guess we skipped end behavior, but oh well. And then the last one, domain and range. Talia, what's the lowest x value? And what's the highest one? Infinity, awesome. And then what's the lowest y value? How low does it go? It goes below 0. right? 0 is right here. It goes below that, right? But not infinity. If we're talking about the low one, it's going to be negative infinity, and then to positive infinity. Yeah, it is. It absolutely is. Yeah. Okay. All right, all right, all right, all right, all right. Let's look at another one.
How are we gonna? Okay. How are we gonna do this?
I don't know. It's crazy, huh?
We have to do all the points.
I hope not. That doesn't sound like fun. So this one does not have arrows on the end. Okay? So let's keep that in mind when we answer the question. So the first question is it a function, Luis? Yes, it is a function. It passes the vertical line test. So yes, it is a function. What's the next question? Maximum and minimum? Oh, oh, yeah, that's right. Intercepts. Okay. So what's the X-intercept, McKenna? Right, her? Yeah, no, right where it crosses the x-axis. So what is that? Negative 6-ish. Might be a little less than that, but we'll call that one good. How about y-intercept? No, now we're crossing the y-axis. 4.2. Okay. Oh, yeah. Because it's a little bit past negative 6. Yeah, that's fine. Okay, then are we maximum, minimum? Or are we increasing and decreasing? Both? Jiren? I don't remember what's next. Increasing and decreasing? Okay. Okay, Jaren, where is this graph increasing? What x values? So it starts going up right here. Negative 8, right? Okay, and then it keeps going up until it gets to x equals nope, what x value is right here where it stops going up? X value, 0. So it's increasing from negative 8 to 0, and then it does it again from right here. Nice job, Darren. Glad to have you back. Okay, and then real Jaren, where is it decreasing? Where is the graph going down? Real Jaren. Six. Awesome. Okay. What's that? Because we're looking at the x values, so it starts going down at this point, which is where x equals 0, and keeps going down until x equals 6. Okay. Okay, Matthew. What's the maximum? What's the highest y value on this graph? Yeah, 5. This endpoint is actually higher. What is the smallest y value on the graph? Nope. It happens at x equals negative 8, but what's the y value there? Yeah, okay. Okay, if I could draw your attention real quick, Dylan. Matthew first said when I asked him what the maximum is, he wanted to say that point right there, but it's not the highest point of any of the points on the graph, but it is, right, because the one over here is higher, but it is the highest point around, and so it does have a special name. This is called a relative maximum. And so I'm a relative maximum because I'm the tallest guy in the room, but I'm not a maximum because I'm not the tallest guy on the planet. Okay. This one right here would be called a relative minimum. Just so you know. All right, then the next question is domain and range. Yeah. Not really. I kind of just am used to it, you know, so I know what I have to do. When you're a tall person, you learn pretty quickly two things. One is to just duck when you go to any doorway. Because have you ever hit your head like right on the, oh man, it hurts so bad, makes your eyes water. And then the other thing, when I get up from a table, like if I'm in a restaurant or something that I'm not familiar with, I always look up to see if there's a hanging light that I'm going to smash my head on, because that is super embarrassing and also hurts. So those are the two things you have to look out for. Huh? Yeah. Good. I taught you something useful. Okay. This stuff? Yeah. Remember that. Yeah. Always check. Yeah. Okay. Who did I get? Matt? No, I just got Matthew. Nathan. It's you. Um, so now we're doing domain and range. Or we? Oh, sorry. Symmetry. Okay. Does this have any symmetry? Does this have any symmetry? Is there anywhere you can draw a line? It'll be the exact same on both sides? No. So no symmetry. Okay, now are we domain and range? Okay. All right, Riley, what's the domain? What's the lowest x value that the graph is at? I think that's -8. Yeah. And then what's the highest x value the graph goes to? Okay, and how about range? Same thing, but with the y's? I like the how about -3? Okay. Okay, yeah. Is that it? Is that all the questions? Okay. For that one. All right, then we reset here. This one only has 1, 2, 3, 4, 5 points. So that's kind of weird. No, because I need to be changing the graph. Okay, Dylan. So the first question is it a function? Yes, it's a function. Does it seem like these? No, we're not going to have homework. We're not going to get through this lesson. Okay, next question. X and Y intercepts. Luis? Oh. X and Y intercepts? Yep. Where does this... How many points are there? Well, but you are like trying to guess if we could... But there's not a point there, right? So that means it's actually none, because it doesn't actually go there. Good luck. There's not an arrow. There's not an arrow there, so it's just the individual point. How about the Y-intercept? What point is on the Y-axis? Also none. Yeah. Okay. And I don't feel like we can talk about decreasing if they're just individual points, right? Because they're not connected, right? Okay, so let's go to maximum and minimum. Yeah, because we got that. What's the maximum? 3. What's the minimum? Nope. Nope, not quite. Nope. 1 is right there. It looks like about 0.25. Yeah. Okay, then there's no symmetry. So now to do the domain and range, since they're not connected, we have to actually list the x's and list the y. So what's the x coordinate of this point? Well, but 1 is right. Bye, Alexa. Good luck. 0.5. 1. Yeah.
Look what I did.
Nice job. 2, and then 3 and 4. Okay, then the range is the same thing. The stapler is over there by Matthew. The range is the same thing except we're looking at the y values, and we still do want to go from the lowest to the biggest. So what's this y value? What's this y value? 0.25. Yeah. What's this y value? And then 1 and 2 and 3. Okay? Okay? Yeah, that's it for that one because we can't do increasing or decreasing because it's. We would if like there was actually something at stake for us to do it, but we're not going to do it. No, let's just not even. That just looks like someone puked on the paper. Okay. Oh, but 6 and 7 are easy enough. Are these the last two of these? Okay. Really? Gosh, don't we have like 12 minutes left still? Double dojo points?
Yeah, because we have so little time, but we can press on.
That's a nice idea, but no. All right, McKenna, first thing we need is function or not. Yes. Yes. Function. Okay, see if I can remember all of these then. The next thing I believe is the X and the Y-intercepts. Riley, what's the X and Y-intercepts of this graph? Thanks. So yeah, right here it crosses. Yep, crosses the the y-axis at -1. Where do you think it crosses the x-axis? What's the coordinate of that little point? 0.25. You good with that? Okay. Okay, then is next increasing and decreasing. Okay, Jaron, where is this graph increasing? And when I say where, I'm asking for the x values where the y values are going up. I think that's -2, isn't it? So this is at x equals -2, and then it keeps going up to x equals 1, 2, 3, 3.5. Okay. Where is it decreasing? Doesn't. Is the next one the maximums and the minimums? Okay. I'm coachable. Alrighty. Oh, I told him. Nathan, maximum? Mm-hmm. And the minimum? -7, yeah. It starts at x equals -2, and then it goes up all the way until x equals 3.5. That's the y value. It's confusing because you're kind of using both. The y values are going up, but you have to say the x values where that's happening. Symmetry, anyone? Nope. Domain and range? Oh, yeah, domain and range. That's the last part? Okay. Okay, let's see if we can get, nope, we get Riley again on the domain and range. Matthew? What are all the x values? I think it's, yeah. Okay. And what's the, oops, I put that in the wrong place. -7 to 10. And that's it for that one. Okay. All right, last one. We got just enough time. It is not a function. Why not? This right here. Here's the dealio, though. This has a hole right there. So there's not actually a point right there. I'm sorry to hear that. Yeah, that's a drag. So it actually is a function. Yeah, because that hole means that point, there's not actually a point there. Okay. All right, what are the X-intercepts? This time there's more than one. Where does it cross the X-axis? 14.5, and what else? $21. Thank you. What about the Y-intercept? Is that 10? 1, 2, no. Where's... Oh, no, you're looking at the right thing. I was looking at the wrong thing. It's way over here. Okay, so yeah, you're right. The Y-intercept is 10. Where is it increasing? Starting right here. So what is that? 6? And then up until 8? Isn't that 8? Okay. And then it does it again from 18 to 21. Decreasing from starting right here, right? So from 0 until it gets to x equals 6. And then it's also decreasing, if this is a roller coaster, you're going down from here to here, from 8 to 18. Awesome. Okay. Yeah, brother. What's the maximum on the graph? 10 is the highest point. What's the minimum? I'm going -2.5. Sure. Okay, I was going to say -3, but yeah, you're right. Not quite there. Okay, no symmetry. What? Domain and range, and then we'll call it a day. Went by fast today. What's the domain? Lowest x value is x value. So it starts right here at x equals, 0, and then it ends right here at x equals, right here, 21. And then the range, the lowest point on the graph we decided was -2.5, and the highest is 10. Okay? Yeah, I'm 6 feet tall, so I'd be like... Okay, we good?